looking at it as a hacker, right? That's basically the approach that I would take, right? If you give me ultra safe software that's been hardened and everything else like that, I'm always going to look for the soft spot, right? And if your firmware on the device, if your UFI, if whatever else isn't PQC protected or PQC implemented, that's what I'm probably going to go after, and that's what we're looking to solve.
Can we upgrade all hardware to PQC? And if not, how bad is the quantum technical debt problem? An NVIDIA architect has some hot takes on the topic that might alarm you. Find out what will be involved in achieving true resilience across organizations in this episode of the Post-Quantum World. I'm your host, Konstantinos Karagiannis. I lead quantum computing services at Protiviti, where we're helping companies prepare for the benefits and threats of this exploding field. I hope you'll join each episode as we explore the technology and business impacts of this post-quantum era. Our guest today is a systems principal architect at NVIDIA and the co-chair of Trusted Computing Group's marketing work group. Thorsten Stremlau, welcome to the show.
Hi, thank you. Thanks so much for having us.
Yeah, it's really great having you here. There's a very timely topic we're going to cover and near dear to my heart, of course, with PQC. And for those who might not know, can you tell us what TCG is and of course, TPM, the major component?
Yeah, absolutely. So, and I guess you've got the right guy because I was really there from the very beginning, right? So TCG is an organization that really had its roots that started back in the late 90s. And so TCG stands for Trusted Computing Group. Back in the late 90s, one of the things that the different organizations were looking at is kind of replacing the smart card, right? But replacing the smart card, which is there to prove that the person is who the person is supposed to be, with actually proving that the computer is who it's supposed to be. So Trusted Computing Group defines, is an industry standards body that basically defines standards for what we call hardware roots of trust, right? And there's several different ones, but these are basically mechanisms that allow you to trust a platform, a system, and also report on its own integrity, right? So that was basically the gist of things back in, I think it was 98, 99, when all of this started. And so obviously TPM, the Trusted Platform Module, is one of our most implemented, also would almost like to call it famous specifications. And the Trusted Platform Module is basically a low-cost chip. It's a tamper-resistant cryptographic engine that sits on a device's board that then basically can, first of all, generate and protect keys. It can perform measurements of the boot process, of its own boot process, of other boot processes, and then basically protect secrets that are stored in it that are tied back to measurements, or also called attestation, right? So that would basically be it. So when we took a look at this, it was all about how we could establish trust on the platform by making sure that the system itself was trusted.
And of course, this is the post-quantum world, and quantum's our big threat. So we're going to dig into a little bit on the topic of how quantum computers threaten that root of trust and what can be done. So with the release of version 1.85 of TPM2 library, what was the primary technical hurdle in fitting post-quantum cryptography on there, right? They're heavier algorithms, and you said chip several times, and chips are obviously not very big. When they're not the actual CPU, they tend to be tiny little things that are support architecture. So what was that like with the resource-constrained environment?
So, I mean, I think we'll get into the requirement for PQC and why that's important a little bit later on. But from our perspective, we have to remember the design principles. Yes, you're completely right. It's a small chip, right? It's not a ginormous HSM that you can lug around with you and carry around everywhere. So cost and size, or capability was one of the things, and I'll get into that in just a second. But there were also several other things, right? In the security world, people don't like the next shiny object. Okay, people like stability. People like trust. And so, we had to balance. We had to balance both dealing with, the typical resource constraints that you would have, as you mentioned, on a small chip, on a low cost small chip. But we also had to make sure that whatever that implementation wasn't rushed and maintained all of the security principles that we've been known for the last 25 years, right? So that was something that was really, really important. So yes. So number one is resource constraints, right? So obviously, PQC algorithms require a whole bunch more in terms of memory, and then also processing, right, in order to work with these keys. So they're a lot more computationally intensive than what you had before. And then, by the way, on this one, again, we had to balance, the performance of the TPM versus opening something up to a denial of service attack, right? By now having it start or staying in a loop where it's just not responding. So that was number one. Number two was also to make sure that everything that we defined, and again, if you're extending the amount of time that it takes to do something or extending the key size, in many cases, you open yourself up to a broader attack vector for side channel attacks, right? Because now your process runs for a longer period of time, and then you can mount side channel attacks. So to answer your question, there were obviously resource constraints, both in terms of costs and memory and computational power, but also making sure that whatever implementation we put in place maintained full security across the entire thing that the TPM has been known for the last more than 25 years.
Yeah, security practitioners do not like shiny objects because they usually come in the form of a 0 day or
yep, that's right, exactly.
Or the worst shiny object to ever hit security possibly, which, let's be real, it's Mythos. I mean, that's like nightmare fuel right now for people, keeping a lot of folks up.
Yep. And again, so looking back at your question, we published the 185 specification, which now actually leverages a lot about. It actually leverages something that we put in place many years ago with the TPM 2.0 specification, right? The very beginning. So we're leveraging the crypto agility that we built back then, and have built that into 185. So 185 is basically now the specification that expresses how PQC is implemented in the TPM. But it's also important, I want to be very, very clear that 185 in isolation does not make up a TPM that is PQC ready, right? You need to pair it with a platform profile, and that's basically 107, that then also tells the TPM makers how to implement it on their TPM, right? So it's a combination of 185 and then also the platform specification 107.
So for end users, what would that mean, the platform profile?
For end users, it doesn't mean a thing.
Okay,
I want to be very, very clear. For end users, all it means is make sure that, actually it does, for end users that are looking for a PQC ready TPM, it's important to make sure that it's 185, it meets the 185 specs, and that it implements the 107 platform profile.
Okay, so they'd have to look in two places then, I guess.
I'm very much hoping that the TPM vendors that exist out there in the world will know to put that step, or at least add that technical detail to their specification documents.
So obviously updates happen regularly. Now we have this added, and this is version 185. So in the future, do you anticipate moving beyond ML-KEM, ML-DSA? Do you imagine adding like future candidates? I HQC is going to be the next one, for example.
Yeah. So again, we do look at stability and not at next shiny object. However, again, we do have crypto agility built into the TPM, right? So we will be able to react to changes. Right now, ML-KEM, ML-DSA are basically the best defined in the industry, and have already, well, I call it proven stability, right? From that particular. So we're starting with ML-KEM, ML-DSA, and obviously we're also retaining a lot of the classic algorithms to also enable hybrid. Right? That's something that's really, really important. And so, yes, we're keeping an eye on, and the cryptographic agility of the TPM 2.0 will allow us to look at other algorithms in the future. But for now, we are focused on those two because they seem to be the most mature, from a definition perspective.
Yeah, and I'm not even sure if this is a question, but you've heard a lot of buzz. Excuse me. You've heard a lot of buzz about the whole Microsoft thing with, for Windows 11, you need, a certain level of hardware, including, TPM. And then everyone got all excited about that and said, okay, now we're just going to install Linux on a bunch of old machines. And I love Linux, but, you have to wonder, are there going to be a lot of machines now that have no chance at truly being PQC safe because of this kind of attack? I mean, that's a reality we have to accept, right?
It is, and that's something that is actually important. Is you can't look at something just in isolation. So I want to be very clear. If you have a PQC ready TPM on your device, that does not protect you against PQC attacks in the future. It protects the platform and the TPM against PQC attacks, but there are many, many other things in the ecosystem that need to meet PQC readiness in order to make sure that that your bank credentials aren't harvested, right? That all those other things that are put in place. And so again, I'd love it if the TPM was this core thing that solved all of our PQC worries. But it really plays the role of providing platform trust, right? Which is the hardware that everything else runs on top of, and being able to trust that. And so we're not introducing any attack vectors below all of that software that's going to be leveraging, the algorithms and doing whatever transactions need to be PQC protected.
And conversely, if someone were to take an old machine and run a super patched Linux build, they're still going to face the possibility of that root exploit.
Absolutely.
Yes.
Exactly. And in looking at it as a hacker, right, that's basically the approach that I would take, right? If you give me ultra safe software that's been hardened and everything else like that, I'm always going to look for the soft spot, right? And if your firmware on the device, if your UEFI, if whatever else isn't PQC protected or PQC implemented, that's what I'm probably going to go after. And that's what we're looking to solve. So
in a few years, people are going to be complaining all over again about the older devices. Get ready for that next wave. So one of the biggest threats people think of is harvest now, decrypt later, and that's a real thing. Sure, harvest packets, and we can get into the whole discussion about like how realistic harvest now, decrypt later is as an attack. I mean, the thought that if you can do 70 some attacks a year because quantum computer takes a few days, are you really just going to go after messages? I don't know. You might want to do the other types of attacks we'll talk about later. But we still do have to protect against this. So how does implementing PQC at the TPM level help this? Does it mitigate this at all?
Yeah. So kind of going back to the answer that that we went through just before, right? So this is something that is important. So we do know that there are organizations today that are already harvesting data and recording it in great quantities today, right? But as you said, I don't think they're harvesting my email transactions to whatever I'm doing now. But there are probably going to be higher value targets, right? Pharmaceutical companies, banking customers, cryptocurrency. Is another one of those big things, and the transactions that happen, right? By the way, we've also heard of several government institutions that are performing harvest now, decrypt later attacks, or won't call them attacks. I'll call them tax storage, for lack of a better word, right? So, they're just basically checking to see are people hiding tax revenue in cryptocurrency? And remember, statute of limitations is very, very long on those kinds of transactions. So, that might be one of those things that pops up once cryptographic relevant computers start popping up, right? So yes, it is very, very important. I do believe that harvest now, decrypt later attacks or scenarios, I'll call them scenarios as opposed to attacks, are happening today. From PQC perspective, again, what I said before, the TPM is extremely important. TPM is extremely important because it builds that root of trust at the platform or device level, right? And I do mean in IoT devices, in automobiles, in PCs, in servers, in graphics cards, in all sorts of other different types of things like it, right? So you need to be able to protect the underlying platform as best as possible. It basically is then that's quantum safe supply chain protection that you would put in place. But all of the implementations and solutions that are implemented above it must then also implement PQC readiness, right? Otherwise, that login that you just performed, yes, great. It's running on a very, very secure platform, but it's still using,
still being harvested and decrypted.
That's right. It's using an AES, 1024 key that, well, by the way, will only take 2 hours to decrypt, right?
Yeah. So yes, I just wanted to clarify that. Yeah, we're talking about a different kind of protection here. Just securing that process, that root isn't going to help you if you're sending messages and.
Exactly.
So,
exactly.
Yeah, as I would say, if it's broken, it's broken, right? So even though it's unlikely that your email will be harvested and someone will spend 5 days decrypting it or whatever it ends up being, you can't trust it at that point. Just like other collisions and things in the past, you haven't trusted encryption up to that, and we've moved on from SSL, for example. We moved on TLS. But now let's get on to like what an attack really would look like. So I believe on Q-Day, the biggest thing that'll start happening is forgery, harvest now, forge, that kind of thing. So quantum computers threaten digital signatures. And that could forge an identity, but let's face it, that it can also affect these devices, and as you were saying, the root of trust. So how does this TPM specification ensure that firmware updates and boot processes remain resistant? Because that's a great attack vector. It
is, and this goes back. So the industry has been focused on this for quite a long time. There's a NIST specification called NIST SP 800-193, which defines platform resilience. Mm-hmm. And then, by the way, that's just simply if I bork up my firmware, there's a backup copy that I can recover. By the way, now you have 2 copies of your firmware. You have your primary and you have a backup. And then, by the way, also typically on PCs, we have something called the capsule update, right? Which is something, oh boy, that in a previous life I fought very, very long and hard to make sure that the industry adopted, right? Which makes that whole firmware process of updating the firmware much, much easier, right? And so the important part is that resiliency for firmware updates, attestation for firmware updates, and then also measurement for firmware updates. Those would be the three important things. So what we need to do in the very, very first bit is we need to protect against somebody modifying the content of a firmware and introducing their own code, right? And by the way, we have seen live attacks on this. There are actually UFI rootkits that are already out there. We've also seen a number of, and much more prevalent in the Wi-Fi router space, right, where the entire Wi-Fi router firmware was replaced with some really, really bad stuff. And so by being able to sign the firmware image with a PQC algorithm, that's probably going to be your very, very first step, so that the platform can, beyond any reasonable doubt, know that the contents of that firmware were not modified in any way, right? So that's number one. The second step then comes in terms of understanding was it applied properly, and then also understanding where that firmware came from, right? And then lastly is the resilience, is if something goes wrong during the firmware update process, is being able to recover from it. So those would be the 3 steps that are really important. And secure boot, by the way, I want to be very clear, you can implement secure boot without a TPM, but you're losing the platform measurement part of that. So the TPM works in conjunction with secure boot in order to make sure that the platform is secure, and then the chain of the OS and all of the applications that come after that are implemented in a secure way.
Yeah, I view it as like patching a bunch of potential holes all the way up.
Yep. Exactly.
Pop in. So PQC keys and signatures, as we mentioned, more overhead, they're larger. How do you guys handle then the potential for bloat in memory, increased latency in command execution, right? This thing has to still perform.
Yeah. So again, TCG is made up of a lot of very, very knowledgeable, experienced people from this industry, right? Want to be very, very clear. We've got some pretty smart minds in terms of all of this. Is yes, making sure that the computational power in terms of on the TPM meets that specification was one of the things that we made sure of in this definition. And then also, obviously, making sure that the larger algorithms and the larger keys that we're now using are able to be segmented in a better way, in a very, very secure way, so that, again, we don't leave ourselves vulnerable to some sort of side channel attack as we go through this, right? So it wasn't easy. It wasn't easy, and then that's one of the reasons why it actually took so long to come out with it. By the way, we're still ahead of schedule, so we're actually doing really, really good. But we really wanted to make sure that the TPM implements all of this in a secure way and remains a trust anchor for all of the PQC implementations at a platform level.
Okay, and were there any challenges then in enabling hybrid? I mean, you mentioned how you keep, the old cryptography in place. Was there anything else that had to be done specifically to support hybrid? Or?
No, the NIST is obviously recommending all of the modern algorithms, while other international organizations abroad, Europe and Asia, are actually taking a slightly slower approach and going with a hybrid classical plus PQC, right? Mm-hmm. Again, we know that this is happening. And that's why we maintained the capability for both, and we also have that capability. And 185 does allow for both classical and fully PQC mechanisms to coexist. There's key exchanges, signatures, and everything else that goes along with it. We see hybrid as a path to full PQC. Eventually, and again, from the way that we've implementing this, it's really with 185, we're looking to reduce the risk of the transition as much as possible, right? To make it possible for someone to make that migration. And by the way, let me be very clear. We understand that nobody's just going to click their fingers and then immediately move everything to PQC overnight. Yeah. And that's one of the things that we really wanted to do as part of that. That was really important.
So when 185 came out, the idea was that all existing TPM2 chips are going to be able to run it, right? Or there's not going to be any kind of like rip and replace required?
Oh boy, no. Unfortunately, that's so from a DTPM perspective, the added memory and some of the other things that are there do mean that it is going to be a hardware replacement. So we will not be able to do in-field firmware updates. And there is one other thing is you have to remember the TPMs that are out there right now, their firmware and the firmware signatures are all classical cryptography, right? The signatures on the firmware of those devices and the way that they measure their integrity is based on classical algorithms, right? So, and you need to be able to put that's one of the things, you need to be able to put a PQC algorithm protection in place for even the TPM firmware, as I mentioned, earlier, in order to make sure. And then that, unfortunately, is something that requires a factory, right? In the factory, depending on what algorithm you have, is the one that then injects that key into the factory. Now, we are looking at obviously being able to leverage things like, for example, an endorsement key regeneration or something else like that on the platform to be able to cover more scenarios. But, we still have some time. I realize that the time is short, but we do still have some time for platforms to be able to adopt TPMs that are fully PQC ready from the very, very bottom layer and don't just bolt PQC on in the background.
So so some devices, I mean, it sounds like most devices then you're saying really can't be fully PQC ready?
Yes, that is right. So what's happening right now is that the TPM vendors that are adopting 185 and 107 are now basically in the process, have been or are in the process. Obviously, our member companies have seen this happen. They themselves have been working on the specification for years now. So this isn't exactly a surprise that this was published. And so the TPM vendors have been working for many, many years, and that goes back to my earlier answer. It is going to be important that procurement, or the people that buy these devices that require a TPM with PQC, look at, does this TPM implement 185 and 107, right? And that's going to be one of those things is an older TPM specification will still implement a lot of classical algorithms and not have that bottoms up protection. So yes, it will require a hardware transition.
Yeah, so that's the whole device. Obviously, I mean, you can't. I guess a motherboard if it's a server or something.
Yeah, it not necessarily. There are implementations, but in most of the cases, it will require a hardware upgrade on that side. Yep.
Yeah. Okay. So that's potentially scary, right? Because of 2029 being the first possible threat. So quantum technical debt, if you go all the way down, is a real worry now, right?
Oh, absolutely. Now, by the way, let me be very clear. Servers, network routers, these, the higher end devices that cost thousands, if not hundreds of thousands of devices, those don't get again, shiny objects. Okay, those don't get replaced, easily and overnight.
Mm-hmm.
They're a core part of the infrastructure. Now from a performance and power perspective, there is still, a fairly short life cycle, but you have to remember that and I'm not going to mention a company, but a large server manufacturing company is not, they don't do things like they do for phones. They're not going to bring out a new server every 6 months to a year, right? It's not consumer behavior. It's enterprise behavior, which is stability over a long period of time so that you can certify all of your apps. So yes, you are completely right. Now, you have to remember that if we issue, and we have issued PQC ready TPMs now, it might take 2 to 3 years for that server vendor to implement that TPM on their platform because their roadmap does not look for adopting that. So yes, this is a real worry for the industry.
Wow.
And the urgency in the industry is you need to make sure that you get ahead of it because the transition time can be very, very long. And I'm just going to use one more example, if I may. Look at your manufacturing sites. Look at your power production sites. I mean, I've got one around the corner. I don't see people swapping out that equipment all that often, right?
Mm-hmm.
And by the way, yes, those all have IT stuff in them that, and so it may even take decades before all of the infrastructure that we have does it. And it's all about risk mitigation, right? So where can I put PQC in place that makes financial sense and that then basically mitigates the most amount of attacks, right? So those are the types of discussions that companies need to have right now about their infrastructure.
So we'll need some kind of new defense in depth to consider that horrible overlap period that could happen, right? There could be a big one.
Absolutely, and we actually, as TCG, we did a survey. We did a survey not too long ago. It was and it was scary. Well, the survey wasn't scary. The results were scary. We interviewed all sorts of IT security experts, and we asked them about their readiness. And their awareness of PQC. So what was really interesting is, and you can, if you'd like, you can get access to that on the TCG website. It's free. We publish it there. We interviewed, and basically all of them, or a very large majority, like in the high 90s, are aware of the PQC threat. At least they say they're aware of the PQC threat. We didn't quiz them on it. The second thing, but then we asked them is, so how ready are you to implement PQC? And we also got a fairly high response rate from them saying, yes, we will be ready in order to adopt PQC. Then we asked them one more question, which is basically, have you done any baseline analysis of where your vulnerabilities are in order to deal with this? And that's where the scary part came out. So all of them understand the PQC threat. All of them think that they're going to be ready. Like, I don't know, and I don't, please don't, I'm going to say a very small percentage, and I can't give you the exact number off the top of my head, basically said is, yeah, but we don't really have an idea of where the threat is in our infrastructure. So,
everywhere.
Yeah, we did an analysis of all sorts of different industries as well. So that was one of the things that was really, really scary.
Wow. Okay. And so how does this affect, let's say, government? Like, let's say the difference between enterprise and government. Like, what do you see happening? Do you see one acting faster than the other, maybe on this kind of like swap process?
Yeah. So the government is obviously the most regulated, right? That's one of the things is if you get that central organization like NIST, like NIAP, or something else, NSA, that basically says this is basically it, and if you don't meet this criteria, it's not happening. That is one of the good things. And in the government, in the industry sector, it's okay. This is what we need to do, and then CFO, do we have enough money in order to do it, right? Or does it make financial sense? Now, I'm not saying that governments don't also have to do this, but it's a little bit different. So we do know that there are that our governments, at least internationally, because we've been speaking to them, are very aggressive in mandating the adoption of a CNSA 2.0 in the platforms, including the TPM, and are starting to actually make provisions that only equipment that is CNSA 2.0 compliant or PQC ready can be bought, can be on procurement lists to be able to be bought, right? To be able to meet that. So that is the good thing. We're hoping that the other industry or critical infrastructure and other critical industries and enterprises will recognize this as well, right? You have to remember this can be detrimental to your organization if it turns out that your, I don't know, RSA 1024 key that you've been using basically caused your banking database to be stolen, right? And so, there's healthcare, HIPAA, there's many, many other examples. So we do believe that government is going to be first. Government is going all in as far as we can tell. But we also know from our members and our member companies that there is an immense focus from all of the industry leaders in order to do that, including some other ones.
Yeah, you're literally wearing your NVIDIA hat. So I do want to talk about NVIDIA for a moment, but before we get to that, I have a question to ask. You're not a server manufacturer, obviously. you don't deal with that, right? But when would you expect that a typical server catalog, hey, these are our new offerings. When would you expect that would really be ready to support this? Like if companies were buying, would it be 2028?
2027.
2027? Okay.
Yeah,
So that's
so,
still 2 years shy of the first possible Q day that everyone's worried about now, 2029.
That's right. So we do know that the mandate from many government organizations and other ones is that any RFPs or requests for pricing or requests for quotes will include a PQC clause or requirement from the 1st of January of 2027. Okay. And by the way, I also know that the industry is aligning, and major PC manufacturers, major server manufacturers are aligning to that date as well.
Okay, so starting 2027, we should be able to start buying things that will be able to usher us into the new age. Then there's that horrible, horrible nightmare of, imagine old water processing plants and all these places that keep machines for 30 years, and you're like, I don't know.
And by the way, I want to be I don't want to paint a doomsday scenario. I want to be very, very clear. You can protect those infrastructures, sure. Right? It's not like if you put them behind a nice PQC ready firewall, right? There are protection mechanisms, but they are individual to every company, which is why I can't give some standard advice, right?
Air gapping, there's other things that can happen. Yeah,
exactly. But again, the importance starts at the platform trust. So again, can I trust that firewall to protect my non-ready infrastructure? Right?
Those better be upgraded first.
Exactly.
Yeah, that sounds true. So now back to your NVIDIA hat.
Oh boy.
So you work obviously on, I guess you work on chip level, right? At NVIDIA, basically.
Yes. Yeah. Well, chip and software level.
Chip and software level. Okay. Yep. So your plans then at NVIDIA to incorporate this, what do those look like?
I can't go into the exact details, but NVIDIA, in just by the way, by nature of us being on part of the board of the TCG and also having large representation in TCG, we do take this extremely seriously. And I can tell you that's one of my roles, and we've got many other team members. We are looking to make sure that we adopt all of the best processes, in our products as much as possible, right? So looking at PQC implementations for firmware signing and firmware attestation. Looking at implementing DICE, right? That's another TCG standard for the rest of the platform measurements that then extend beyond just the hardware into other software areas, right? No, absolutely. And by the way, we also create servers. I do want to be very, very clear. So it's across our entire portfolio, whether it's that the Jetson, right, which is our actually small kind of IoT device. Actually, probably, one of our SoCs is in the Nintendo. Oh boy, I forget what it's called. I'm not advocating to anybody to buy this. It's not the Game Boy. Oh boy, my son has one of them.
I don't know.
That one. Exactly.
Yeah, the one with the two little Joy-Cons or whatever, right?
That's exactly.
I don't play games, so no one can make fun of me. I'm sorry, I do not play games.
Same here. All I know is my son bugs the hell out of me.
Red and blue or something, and everyone's gonna laugh at me, and that's fine. I accept.
That's right. So and looking at a small chip in that, all the way up to the $100 billion data centers that you can buy from us. That whole portfolio, from our perspective, is being aligned with CNSA 2.0 and PQC readiness as quickly as we possibly can.
Yeah, no, that's great. And what I meant is, it didn't sound like you were like, in charge of servers, that kind of thing.
Okay.
Yeah.
Okay.
Yeah. But yeah, I do know what NVIDIA makes, and of course NVQLink and all these other new advances. I would hope that as you're all working towards enabling quantum in those ways, enabling error correction, enabling other things, that you're thinking about, well, this brings with it threat. So we have to also be ready for that side of it, right?
And it is important. It's it's not just about and in this particular case, it's not just about the hardware. Again, remember, go back to oh boy, the question that we had a long time ago, which is, about the harvest now, decrypt later, right? When we take a look at running AI workloads on these platforms, again, it starts with the trust of the platform itself, right? And then, by the way, we've built out a whole model about this where, okay, so now I know that the server that's running the AI is secure, right? With my measurement. How do I know that the sensor or the camera that's out there is actually delivering the right picture, right? Or the right sensor data? How do I know that somebody hasn't modified that? And so now it's also about attestation and trustworthiness of the sensor network and the data network that's feeding into my AI. So that's kind of it.
Stuxnet.
Then we have
trust your screen.
That's right.
Yeah,
exactly.
Some kind of attack. Yeah.
That's right. Then we have the AI or the edge compute devices, right? You're probably not going to be connecting 50 million cameras to one server. You're going to be connecting those to one edge compute device and then feeding it back into your model in the back end. So again, now we need to do the same thing for that edge compute device, right? We need to make sure that that is secure and that it implements everything else like that. And then, by the way, we obviously have the server. We then have to make sure that the AI models that are run in a secured environment, right? And then there's also another aspect, which is in the training, right? So, if you have a good AI model, there's basically a churn, right? Where, there's an answer that was incorrect, or there was something that was an anomaly. It gets corrected and then it gets fed back into the system. So that, by the way, is also an attack vector. So how do you know that the adjustments to your model that are coming back from training haven't been modified and again attested for it? So basically in this model, and that's also something that that we're taking a look at from a TCG perspective, is how can we apply TCG standards and technologies to make sure that we cover, again, the entire ecosystem of that AI. But I'm going to go back to the beginning. We only provide the root of trust for the devices. It's also still up to the manufacturers to then implement the PQC things into their software, into their embedded OSs, into whatever other things that they're doing, right? We're only a small piece of this ecosystem.
Yeah, you do all these things. People use your gear to train AIs, but then after that, anything can happen. I mean, they can be applied in any way, shape, or form. That's
exactly
101. Yeah, definitely. And I apologize for not remembering Nintendo Switch before.
That's it. Thank you.
But I redeemed myself by instantly being able to compare your attack vector to Stuxnet, which is an older hack than a Switch as a device, I believe. So I'm okay. I'm good. It's just,
right.
Again, gaming's not my world. No offense, considering you work for NVIDIA.
No, and by the way, as I said, I know I couldn't remember that. I'm not kidding. I was coming up with Game Boy.
It's funny.
And also the Wii. So more in my generation.
Yeah, see? So look at that. We don't have to be gamers to be involved with the other amazing things that your silicon is doing. That's great. So yeah, thanks so much. This was really illuminating. I hope it gave some people a move to act, because wow, over the next couple of years we have a lot of work to do, and I'm glad you guys are pushing the envelope like that.
Yeah, absolutely. And again, by the way, and I do mean this, as I was wrapping it up, is we know that companies don't necessarily don't have the skills. We have the specifications are open. Mm-hmm. You can go, you can read them. You can look to see how the industry leaders are implementing these, and then use them, even if it's for a non-TPM application. Please do leverage the resources that we have. And by the way, the other thing that I have to say is, if you are creating hardware or software, please make sure that you look at our specifications to implement them, because that's going to be really, really important. We are the bottom, but we're the very important bottom part of the entire ecosystem. And if you don't leverage that, your ecosystem collapses. Yeah,
we have to build on a good foundation for the future. Absolutely. And
correct.
I will, of course, put all that in the show notes so folks can find that and read it. And Thorsten, thanks again.
Thank you. Pleasure.
That does it for this episode. Thanks to Thorsten Stremlau for joining to discuss TCG. And thank you for listening. If you enjoyed the show, please subscribe to Protivity's The Post-Quantum World, and maybe leave a review to help others find us. Be sure to follow me on all socials at Constant Hacker. That's Constant with a K, Hacker. You'll find links there to what we're doing in quantum computing services at Protiviti. You can also DM me questions or suggestions for what you'd like to hear on the show. For more information on our quantum services, check out Protiviti.com or follow Protiviti Tech on X and LinkedIn. Until next time, be kind and stay quantum curious.